with Rockwool, then added another layer on top, sealed everything with membrane, set up the battens, and finally wrapped the whole house in timber cladding. Plenty of tricky parts along the way. Let's start from the beginning of this facade build. From the outside it looks halfway done, but that's just an illusion. This breathable membrane is temporary, just protecting us from wind and water for now. Let's step inside. As you can see, for now it's just a skeleton. All of this will be fully insulated with this Rockwool insulation. It's always satisfying to cut these open and watch the wool expand, but these are leftovers, so it didn't expand much. I'll show you the real effect when the new packs arrive. Before we install the wool, we need to remove the wind membrane from this section. Most people would leave it on and install the insulation from the inside. We're doing it a bit differently, and this way we get access from both sides. With this Rockwool, it's actually a pretty straightforward job. The framing cavities are made almost the same size as the insulation, so everything lines up well. Only in a few spots do we need to trim it slightly narrower to get a proper fit. For the rest, we just cut it to the height we need, fit each piece into the cavity, and let it sit tight between the studs. No forcing it in, no over-compressing. It should hold itself in place and fill the space evenly. And finally, the rest of the insulation arrived. This should be enough for the entire build. Like I mentioned earlier, removing the membrane gives us full access to the cavity. With the membrane on, you only see one side of the insulation. It might look fine from the inside, but you can't tell if it's bulging or getting compressed on the outside. By opening it up, we can check everything properly and make small adjustments if needed. It also makes it much easier to cut around diagonals and angled braces. When the membrane is removed, we can see the exact shape we need to follow. Instead of measuring everything precisely, we can mark it directly in place and trim the wool to fit. That saves time and gives a much cleaner result around those tighter areas. With the first floor walls insulated, we can now move up and continue the rest of the installation on the second floor. It's a bit tricky since there's no proper floor here yet, so we have to rely on walking over these 1-inch boards. First, we bring some of the wool up so we have everything ready to keep working. And like I mentioned earlier with these new packs of wool, it's always satisfying to see them expand as soon as you open them. Right now we're installing the main insulation between the studs, but this wall will end up with several insulation layers. Later we'll add rigid Rockwool boards on the outside, and from the inside, there will also be another 2 inches of wool behind the vapor barrier. All the joints between these layers are staggered, so they don't line up with each other. That helps reduce thermal bridges and keeps the insulation continuous through the whole structure. And now only a few of the trickier parts of these walls are left. The first one is closing the gaps in the sidewall between the roof rafters. These spaces aren't the standard size for Rockwool, so each piece has to be cut individually to match the gap. To keep the cut straight, we simply use a long level as a guide. We place it along the line we want and run the knife along the edge to get a clean, straight cut. Then we need to cut this piece at an angle so it matches the roof slope. First, we measure the lowest point of the gap and the highest point near the rafters. We start by marking the lower measurement on one side of the wool and drawing a straight line across the whole piece. After that, we flip the wool over and mark the higher measurement on the opposite side. Now we stand the wool up vertically and cut along those 2 lines. This creates the angle we need, so the piece follows the roof slope and fits tightly into the gap. When installing wool near the roof, you also need to make sure it doesn't push the membrane outward. If the membrane gets pushed up, it can change the way water drains along it and direct moisture toward the rafters, which over time could lead to damp wood and possible rot. So the wool should sit tight in place but without pressing against the membrane. And with that done, we're only left with the gable walls. There's still a lot of cutting here but much less measuring with the tape. Most of the pieces can be marked directly in place and trimmed to fit. First, we cut the wool to match the angle of the roof. But since the end roof rafter sits inside the gable wall, we also need to trim the wool around it so the insulation sits flush with the outside of the wall. To do that, we place the already angled piece back into the gap and mark the position of the rafter directly onto the wool. Then we take the piece out again and cut along the mark we made following the rafter. Since the rafter thickness is 2 inches, that's the amount of wool we need to remove from the piece, so we mark that depth and carefully cut it out. That way the insulation can sit neatly around the rafter while still staying flush with the outside of the wall. One important thing when cutting the wool, it's best to make the piece about a 1/4 inch bigger than the gap. That way it compresses slightly when you place it in, helping it sit tight and preventing hollow gaps around the edges. Then we give it a quick pass with the insulation knife to straighten out any folded bits, so the wool fills the whole gap properly. With that, the first layer of insulation is nearly done. Only the roof section is left, but we'll come back to that later. For now, let's move on to the next stage. First, we screw this 10 by 10 starter timber along the bottom of the frame. This supports the rigid Rockwool boards that will be installed on the outside and gives us a solid base to start from. It also helps close the cavity at the bottom, reducing the chance of pests getting inside. And finally, we can install the final exterior insulation layer before we start framing for the timber cladding. For this, we're using 30mm rigid Rockwool boards. We install the boards horizontally, making sure the joints land in the center of the studs. That way each board has a solid fixing point and the insulation connects properly across the wall. You might be wondering what these blue pieces are that we're installing together with the boards. I'll explain them a bit later. For now, with 2 rows done, we reinstall the wind membrane before the end of the day. Since we're doing this during winter, the weather can change quickly, so keeping the insulation dry is critical. To lock this membrane in place for good, we install these vertical timber battens. We cut them to the height of the top row of the boards, not to the height of the membrane. That leaves some extra membrane above the boards. When the next row of insulation goes in, we can simply peel this top section back where it's only stapled. This lets the new boards sit tight against the ones below, and the membrane can overlap again before the next row of battens locks it in place. Row by row, we keep building the layer up the wall, making sure everything fits tight and stays aligned. This keeps the insulation continuous as we move higher. With the next piece of membrane, we start by stapling the top edge at the height it needs to be. We make sure it overlaps the previous section by about 15 to 20 centimeters. Then we seal the joint with weather-resistant tape so the membrane works as one continuous protective layer behind the facade. This overlap and tape helps stop water from getting through the seam and protect the structure behind the cladding. These boards also act as a wind-resistant layer on the outside of the wall. By running them across the studs, they help cover those thermal bridges. And as you can see, we keep getting caught by the rain, which is exactly why we only do a couple of rows at a time. And just like that, next day we've got almost 8 inches of snow on site, adding another task to the list, but at least no more mud around the site. With the snow out of the way, we move on to the next wall. We left the membrane from the previous wall a bit longer, so we can overlap it around the corner onto the next wall. That way it works as one continuous layer around the whole house. This wall is going to be a bit taller since it has a gable. With our 10-foot scaffold, we won't be able to reach the top, so when we get there, we'll be making our own DIY scaffold. We could rent a taller one, but where's the fun in that? When we set these boards, they don't always stay in place on their own, so we temporarily fix them with screws where needed, then remove them before installing the membrane. With one layer of these boards in place, we add these blue spacers where the studs are. We install them by cutting a small section out of the board so the spacer can sit tight against the stud. We position them halfway over the board joint, so one spacer supports both the top and bottom boards. For the second layer, we stagger the joints from the previous layer so they don't line up, which helps reduce thermal bridging and keeps the insulation layer more continuous. When cutting the boards, we make sure the cuts are as straight as possible so the joints fit tight and don't leave any hollow gaps. Once all the cutouts for the spacers are done, we fill those gaps with expansion foam, since these spots can become weak points in the insulation. You might be wondering why we need these spacers. They transfer the load back to the studs and help stop the battens from compressing the insulation when everything gets fixed in place. And to prevent these spacers from moving until the foam sets, we fix them with screws. While we wait for the foam to set, we mark where the top of the membrane needs to sit and transfer that line across the whole wall using a level. That way we can fix it straight to the studs and know the membrane is aligned properly, since we only fix the top for now and the battens will be what actually lock it in place. Once the foam sets, we take out the screws that were holding the spacers in place and trim off any excess foam. So when we install the membrane, it sits flush and the battens fit tight against the spacers. For the next section, as we get closer to the gable, we first need to cut around this wall plate that's sticking out for the balcony. We transfer the line of the plate onto the board using a level from top to bottom, then measure the depth we need to cut out. Once the piece is sitting nicely in place, we cut the overhang so the board ends halfway on the stud. That way we can join the next board to it, and both boards have a solid fixing point. To fit the board by the gable, we first find where a full board can fit and mark that point. From there, we measure the length of the board so we know where it should end and make a mark there. Then we measure the height from the lowest point and the distance between those 2 points. We transfer those measurements onto the board, line up a level between the marks, and make the cut. This should match the gable angle. And with this small piece in place, we can seal all the boards with the membrane. We trim off the excess by following the gable line with a Stanley knife. We don't really need to worry about damaging the soffit here, as this area will be covered with cladding boards. Then we go over everything and seal any loose edges or joints with tape, making sure the membrane is fully closed and continuous. We check every seam, corner, and overlap, and if there's any opening at all, it gets taped. Once everything is sealed, we mark where the spacers are so we know exactly where to place the battens and where our fixing points are. That way we're not guessing through the membrane and we can hit the studs clean every time. These vertical battens do two jobs. They lock the membrane in place and create an airflow gap behind the facade. And with this done, most of the exterior installation is complete. And we can move on to installing the horizontal battens. This is the final step before we start cladding. For the bottom batten, we lift it about a 1/4 inch above the starter timber we installed earlier. That leaves a small drainage gap at the bottom, so any water behind the cladding has a way out and the wall can ventilate properly. Once the first end is fixed, we run a spirit level across the batten and set it level. This batten is the most important to get right, since all the others will follow it all the way up the wall. We make sure all the ends of the boards are square so when we join them, they sit tight against each other and don't leave visible gaps. For a more precise cut, we use a circular saw instead of a jigsaw. A miter saw would be perfect for this, but we just can't be bothered bringing out that big tool for now. When we've only got about 2 inches to fix these two boards in place, getting the batten end square is crucial, otherwise we lose fixing surface and the joint won't sit tight. With the first row of battens in place, we make 2 identical wooden spacers, 20 inches long. They help us keep the spacing between the battens consistent without measuring every time. At the wall ends, we leave the battens sticking out slightly, so the battens from the next wall can connect and tie everything together. For now, we just lock it in place with 1 screw at each fixing point, but with 4-inch battens, that's not enough. So once everything is lined up, we will come back and add more. That stops the battens from twisting and keeps everything solid for the cladding. A crucial thing when doing these horizontal battens is to make sure the joints don't line up, so we stagger them from row to row. That way we avoid weak points and each row helps support the one below. As we install these battens, we spot a few rips in the membrane, so we tape any holes as we go. Now we move on to the gable wall. Working in -16, the camera battery didn't last long, so we only caught parts of it. Have you ever worked in this kind of cold? Let me know in the comments. As we get higher up this wall, our portable scaffold just isn't enough, so we'll make our own. Hopefully it holds us. First, we set 2 20-foot vertical posts in place. We lock them in using 2x2-inch braces, fixed between the battens and the post. Then we add the most crucial part of this scaffold, diagonal braces. They stop the structure from moving sideways and lock everything into a rigid shape. Without them, it would just wobble and collapse. Since this scaffold is quite tall, we run a second diagonal higher up to reach the platform height. 1 long diagonal would flex in the middle, but splitting it into 2 keeps everything much more rigid. Then we add another set of braces at the bottom. These let us fine-tune the posts to plumb, and the straighter everything is, the more stable the whole setup becomes. Once the main structure is locked in, we add 1 more support post in the middle. This helps share the load once we start walking on it. At the top, we add 1 support joist across all 3 posts to give the joists a solid surface to sit on. Then we run joists from the battens on the wall to this support, spacing them every 20 inches to carry the boards we'll walk on. Camera died again, but here's the final result. Now we can finish the top of the gable. For the last 2 battens on the gable, we cut the ends at an angle since they both follow the roof slope and meet in the middle at the top of the gable. This gives us a solid fixing surface for the top of the cladding by the roof line. And off to the next wall. At the top by the roof rafters, we add small batten pieces between them, but not all the way up. There's no point since we wouldn't be able to fix the cladding there anyway, so we set them slightly lower where the drill can still reach. And we're on the last wall, where we've got 5 doors to work around. By the window and door openings, we tuck these battens in about ½ an inch from the edge, leaving some room to work with the window and door trims. We couldn't fit a full batten above the doors since the balcony beam is in the way, so we mark each beam and cut the batten around it, using a jigsaw to get it to fit properly. Adds quite a bit of work for just half an inch of overhang, but that lets us push the batten a bit higher so it sits properly over the door opening. Over the top of these beams, we do exactly the same, since there are another 2 doors to work around. And we add extra battens wherever there are sticking out sections, so all the cladding edges have a flat surface to fix to. And we're left with adding the last pieces around the windows, cutting and fitting each one so it lines up clean with the openings. And with most of the battens in place, we now need to straighten the wall and level everything out, since the timber isn't perfectly straight. We start at the corners, making sure they're plumb. To do that, we place a spirit level on the battens and add packers under one end until it shows level, making sure it's plumb all the way up the wall. And once we know how many packers we need, we unscrew the battens and place the packers behind them, then fix everything back in place to lock it in. Once the corners are set and plumb, we run a string line across the battens. To do that, we tie a small loop on one end of the string, hook it onto a screw fixed into the batten where we know it's plumb, then pull it tight across the wall to the other side and fix it there. Then we add the same size packer on both ends, so the string line stands slightly off the battens. This keeps the line from touching any high spots, so we get a true straight reference to work from. And this way we can see how much we need to pack behind each fixing point to straighten the battens out. And from there it's pretty straightforward. Check, pack, and screw it back in. With all the battens straightened and plumb, we do a quick final check with a spirit level to make sure we can move on to cladding without needing to come back to this stage. To start installing the cladding boards, we add one more batten across all the walls. Since we're not installing full-height cladding boards and doing it in 2 sections, we need a solid fixing point for the ends of the boards. This batten gives us that line, so the top edge of the lower boards has something solid to fix into. And it's crucial to get this batten as level as possible, since it will carry a horizontal trim board that the cladding boards will run into. At the corners, we cut this trim board at a 45-degree angle for a cleaner look. Since most of it will be covered by the cladding, the miter doesn't need to be perfect. Only the front edge needs to line up clean, as that's the only part that will be visible. When we install this trim, we make sure it overhangs the batten about 1 1/4 inch, so it sticks out from the cladding boards just a bit. And we install another batten on top of this trim so we have a fixing point for the bottom of the upper boards. It also locks the trim in place and prevents any movement. Once the trim is locked in place, we install this insect mesh onto the battens. This helps keep insects out while still allowing airflow behind the cladding. Then we fix a temporary board sticking out from one side of the corner. This gives us a reference for where the first cladding board needs to sit, since there won't be any extra trim pieces at the corners. Both boards from each side need to meet flush at the corner. Once the first corner board is fixed in place, we remove our reference board and install the other side of the corner. We fix them together using these small head screws, which let us screw close to the edge without splitting the boards, so the corner sits tight and clean. And with the corners done, we can start installing the rest of the cladding boards, leaving a 2 to 3 millimeter gap between them. This allows for natural movement in the wood, preventing the boards from pushing against each other. Keeping the gap this small also keeps the look clean, so we don't need to add any extra boards over the top to cover the gaps. You've probably noticed this tool we've been using. It helps us keep the gaps consistent and lets us hide the screws from the front of the boards. To use it, we place the board in position, set the tool on it, and push it up against the previous board. The tool acts as a spacer, so it automatically leaves the right gap between the boards. Then we drive a screw through the side using the tool. As it goes in, it pulls the board tight against the previous one while keeping that gap consistent. We keep driving the screw until the tool stops the drill, locking the board firmly in place without leaving any screw marks on the front of the boards. This screwing method is mostly used for decking, but it works just as well for cladding, as you can see. As we get to the window area, we leave it for now since we don't have any leftover boards yet and don't want to cut into the good ones. For now, we move on to the higher section of the cladding. These boards are much shorter. The only thing is, we need to cut around each roof rafter. To do that, we place the board where it should sit and push it up against the rafter. Then we take a spirit level and transfer the rafter line onto the board so we get an accurate mark. After that, we measure the depth of the cut, making sure we allow just enough clearance for the board to slide in without forcing it. Then we cut it out with a jigsaw, keeping the cut as clean as possible so it fits tight around the rafter. With that cut in place, we move to the other side of the wall, because by the window we'll need to tighten the last few boards to fit, and we leave that for later. Normally you could adjust the gaps to avoid this, but since we're keeping them consistent, we cut the last boards to fit, keeping that cut in one straight line all the way up. That way the gaps stay aligned and run clean all the way up the wall. And here we've got this trim to fit. To do that, we cut the boards with a track saw to keep the edge straight and clean. We make this trim out of 2 boards instead of 1 because splitting the cut between them makes it much less noticeable than trimming just one. Instead of taking the full inch off one board, we take half an inch off both, so it blends in and doesn't stand out as much. Then we use an angle grinder to sand the cut edge, rounding it slightly to match the other side. Just light, long movements back and forward. And we paint over the cut. This cladding will get a second coat anyway, but getting to this edge once it's installed would be a mission, so we do it now. Then we wipe off any paint from the face of the board, so the final coat goes on clean and even. With these trim pieces, it's a bit more tricky since our tool isn't designed for this width, so we have to screw them in freehand, still fixing from the side and matching the correct angle. And with this piece in place, the first wall is finished, and we can move on to the gable wall, where there are a lot of tricky parts waiting. First, we need to figure out the angle of this gable soffit. To do that, we push a board up against it, then use a spirit level to follow the angle and transfer that line onto the board. After that, we set the miter saw to match the line, so we know exactly what angle these boards need to be cut at. Once we've got the angle, we cut around the wall plate, so the board fits in place nicely. With all the cutouts made and adjusted to fit, we mark the bottom of the board so it sits tight on this trim. As we started working on this wall, the windows arrived and were installed, so we can now cut out the wind membrane to let some light into the house. We leave a bit of overhang onto the window, so we have enough membrane to seal it properly around the window opening later on. And off we go with the cladding. Normally you would install the cladding first and then add the soffit to cover any imperfections, but in this case the soffit is already in place. So we have to be much more precise to get these boards fitting clean right up to the soffit. The scaffold starts getting in the way, so we need to adjust it a bit to finish this top section. First we add a support joist on the lower section of the wall, running it from the battens to a support post. Then we add 2 2x2 inch support posts, running from this support joist up to the top joist. We keep them slightly away from the wall so they don't get in the way. To lock them in place, we add leftover pieces of batten at the top and bottom of the posts and screw everything together. And to make it more stable, we add diagonal braces to each support post. And finally, we can move the top joist away from the wall so it won't get in the way of the cladding anymore. To be extra cautious, we add a few more diagonals just to make sure we're safe at the top. And now we can finish this gable wall without anything getting in the way. And here we get to the trickiest cut on this gable, right up at the ridge. The hardest part is fitting it in, as there's not much room to move the board around, but we managed to get it in. Pretty proud of this cut. Think it deserves a subscribe. We cut around the windows as we go, getting one more job off the list. When we get to the last window on this wall, we start from the other side again, since we'll be adding a trim piece here. A good thing about doing this trimmed section by the window is that the cuts are shorter, so it's much easier to keep them straight. And with that, the gable is done. Not the easiest way to do it, but it came out alright. And we can finally get rid of this scaffold. Feels like it was much easier to put this up than take it down. And with the scaffold out of the way, we can finish the bottom section of this wall. After that gable, this bottom section feels like nothing. No fiddling with angles, just straight, precise cuts, flying through the boards in no time. Just by the window, we need to cut around the opening so the board doesn't cover it. To do that, we mark the top and bottom of the opening, and mark the depth of the cut. For the long cut, we use a track saw to keep it straight. And for the depth cuts and corners where the track saw can't reach, we finish them with a jigsaw. This cut doesn't need to be perfect, and it's even better to make it slightly bigger than the opening, since it will all be covered by the window trim. And just like that, we finish this gable wall. The rest of the process is pretty much the same as I showed on these two walls, so we'll go through it quickly. We still have the door and window trims to install, but that will be in the next episode, together with the interior work. And with that, the wooden cladding is finished. Not the easiest project since there was no way to hide any imperfections, but it came out pretty sweet. If you want to see more builds like this, hit like and subscribe. You're the ones driving these projects forward.